Dear viewers, welcome to our channel at Steve Gitau 3660. This is the first lesson, online lesson for the Form 3 students. Indeed, we shall be having a series of this kind of online lessons in mathematics and chemistry. You can find videos for Form 3 Maths under the playlist Form 3 Mathematics folder and also Form 3 Chemistry folder. Also, these videos are available on the general platform, and viewers, you feel free to interact with the material that we provide, make comments, subscribe, share, so that we may grow the channel and we may be able to revise through the content. Straight away, I would like us to highlight some of the topics that we are going to have in this series of mathematics videos. One is the one we've begun on, that is solution of linear and quadratic equations. We shall also have mixtures. We are also going to have approximations and errors. We're going to have solution of quadratic equations by various methods, quadratic formula, completing the square, graphical methods. We'll also look at probability. These are some of the topics that pose challenges to learners. Later on, we're going to look at vectors in 3 dimensions. And as we progress, I'll invite feedback from you so that any topic that you feel is challenging, we can have a review of it in the channel. Otherwise, welcome to this lesson, and straight away, let us go towards solving these questions. You find that in this topic, we solve quadratic equations combined with a linear equation at the same time. In mathematics, they say simultaneously. And the big trick here is to identify which equation is linear, the simple equation, or the simple equation. In this case, we have x plus y being our linear equation. X plus y is equal to 13, whereas x squared plus y squared equals 29 is our quadratic equation. Why is it quadratic? And why is this one called linear equation? A linear equation has the highest power of its unknown being 1, whereas a quadratic equation has the highest power of its unknown being 2. Later on, we shall meet cubic equations. In the cubic equations, the highest power of the unknown will be power 3. So that is the way we have developed this material. So straight away, let us look at how do we solve this kind of a set of equations. The idea is very simple. We look at the simple equation, which is the linear equation. We substitute it into the quadratic equation. Indeed, as they say in geography, the smaller river drains into the bigger river. So we shall be draining the small equation into the other equation by first of all rewriting it so that we have one unknown being the subject of the formula. That is to say, in our solution, we shall have this equation x plus y equals 3. We shift this onto this other side. We subtract y on both sides so that we can make x the subject of the formula 3 minus y. And this one becomes our equation 2, the new equation 2. This remains our equation 1. So we are saying that wherever in equation 1 we have x, we substitute this part in x. So our x squared will now be 3 minus y squared. 3 minus y squared plus y squared is equal to 29. Viewers, at this point, a learner may decide to use the quadratic identities in opening the brackets, or the learner may decide to use the expansion approach. Let us use the identity. The identity says that when we have a minus b squared, it becomes a squared minus twice the a and b plus b squared. So this is the quadratic identity that I would like us to use. We use this quadratic identity in opening these brackets, and what does it give us? It gives us, so we have a as 3, so we get a squared, that gives us 9, minus twice these 2, the b is negative, so subtract twice this gives us 6y. 3 times y is 3y, twice that is 6y. Then we have plus the b squared. Our b squared is y squared. So this expansion is for this portion here. We add this y here, so plus the y squared. This is the one we are having here. That is equal to 29. Now with that, viewers, you look at the equation, it has only one unknown. And therefore, we can now easily solve it in any quadratic approach that we would like to have. However, let us put the like terms together. This gives us 2y squared minus 6y plus 9 is equal to 29. At this level, we can take like terms together, that is, subtract 29 from both sides, so that this gives us 2y squared minus 6y. 9 minus 29 gives us negative 20 is equal to 0. That way now, we have an ordinary and a proper quadratic equation. It is at this point we make a decision to reduce on the numbers by dividing throughout by 3. We divide throughout by 3 and we get by 2, sorry, I beg your pardon. We divide by 2. That gives us y squared minus 3y minus 10 is equal to 0. Y squared minus 3y minus 10 is equal to 0. At this point, we decide, possibly we can use the simplest approach, that is factorization. We use factorization method to work out on this one. In this case, we can talk about the product and the sum approach. We look for two numbers whose product is 1 times negative 10, and that gives us negative 10. We look for two numbers whose sum is negative 3. So viewers, take a few minutes. We'll look for that pair of numbers. What pair of numbers can give us a product of negative 10 and a sum of negative 3? Work throughout, takes 1 minute. You can pause on the video, you look for these numbers before I give you the solution, because I would like to have a very interactive kind of session. So viewers, we move on, and I expect that you have negative 5 and positive 2. Let us see. Negative 5 times positive 2 gives us negative 10. Negative 5 added to positive 2 gives us a 3. So it is these two numbers, we are going to substitute them here on the middle term. And that gives us y squared minus 5y plus 2y minus 10 is equal to 0. Now with that, we are going to factorize what is common in the first part, and here we have y into y minus 5. We factorize what is common in the second part, and that happens to be a 2 into y minus 5. From negative 10, if we factorize a 2 out, we are left with negative 5, and that gives us a 0. At this point, we put like terms together. Let's put like terms together. You have this is a multiplier to this, and this is a multiplier to this. The y minus 5 are common factors. So that gives us y plus 2 and y minus 5 as the factors to this set of quadratic equation. So straight away, if we can start with the first part, whereby we are saying y plus 2 is equal to 0, that means y is equal to negative 2. At that point, we ask ourselves, what is the value of x? We come to our simple equation here, which we had said that x will be equal to 3 minus the value of y, And that is leading us to a conclusion that x should be equal to 3 minus negative 2. 3 minus negative 2 gives us that x is equal to 5. X is equal to 5. Now, let's come to the other part. If y minus 5 is equal to 0, therefore we are saying y is equal to 5. What is the respective value of x? What is the value of x? So we come back to the equation and we are saying that x should be equal to 3 minus the value of y, which is 5, and that gives us negative 2. So viewers, at this point, it is very important that we pair our answers. We show clearly the pairing that we have on our answers. In a free space like this one, we put our answers very clearly that x is equal to 5 when y is equal to negative 2. And in another portion of our answer space, we show when x is equal to negative 2, then our y is equal to 5. Now, viewers, these two sets of answers are different. As you can see, in this case, when x is 5 here, x, we are giving it a negative 2 here. When y is negative 2, we are giving y a 5 here. So how do we go about marking this kind of a question? How do we award marks for this kind of a question? So we realize if the student has used this approach, we expect that when the student is able to substitute correctly the smaller or the linear equation into the quadratic equation, this earns the student an M1. Now, the student should progress and make up the quadratic equation, a proper quadratic equation, and this should earn the student an M1. Now, solving this and getting the proper factors at this level, the student earns an M1. Now, with these factors, the student should be able to get the proper roots. That is the answers to the quadratic equation. And once the student is able to get the 2 correctly, we award A1 for both a set of answers. That means we expect that this set is correct and this set is correct, because at this level, the student has very low chance of getting it wrong. So in this kind of a question, the student should comfortably earn 4 out of 4 in his marks. And that way, we are able to see the techniques that we require when we have a quadratic equation and a linear equation. In summary, we are saying, go to the linear equation, develop one unknown as the subject of the formula, substitute that into the quadratic equation so that you develop a quadratic equation with only one unknown, and you can give it in its simplest form. From this point onwards, the student is free to use any approach, and normally we go for the easiest one. The easiest one happens at this point to be elimination method. Learners, I would like us to go to question number 2. In question number 2, we are going to view a similar case whereby we have x plus 3y is equal to 13, x squared plus 3y squared is equal to 43. So, viewers, I would like you to pause on the video, work it out, and then when we resume, we compare the two answers and even the working so that we are able to see how we worked it out. Viewers, let's continue. We have this linear equation, x plus 3y equals to 13. So it is this equation which is linear, which we should substitute into the quadratic one. That is, we make x the subject here, and we have this shifting to this side, and that gives us 13 minus 3y as our linear equation. We substitute this part into that, so that we get 13 minus 3y squared plus 3y squared is equal to 43. So that requires us to work it out the same way we did in question number 1. We use the quadratic identity that we have here. We have a squared minus 2ab plus b squared. And that gives us 13 squared is 169 minus 13 times 3, that it comes to be 13 times 3, that is 39, multiplied by 2 because of twice. And that gives us 78y plus negative 3y. If we square that, we get positive 9y squared. So that portion is for this part. We need to add the 3y squared, and that comes to be equal to 43. So let's continue. We put like terms together. 9 plus 3 is 12y squared. Now we have minus 78y. Then we have 169. To it, we subtract 43. So the 43 comes and subtracts here. So 169 subtract 43 gives you 126, and that gives you a 0. That equation at that point is a quadratic equation. We can reduce on it by dividing throughout by 6 or by a very suitable value which divides 12, divides 78, and we divide 126. If we look at that, we can take on 2. We divide throughout by 2. We divide throughout by 2, and this gives us 6y squared minus 39y plus, divided by 2, we get 63 is equal to 0. So looking at that, there is a common factor 3 across all of them. So we can divide throughout once more by 3, and that gives us 2y squared minus 13y plus 21 is equal to 0. So this quadratic equation now can be solved by elimination, by factorization, sorry, and we just need now to look for 2 factors or 2 numbers whose product is 42, that is 2 times 21, that is 42, and whose sum is negative 13. So viewers, take 2-3 minutes. Let us think about which are these two numbers. Which when you multiply, you get 42. When you add, you get negative 13. I want to believe that you have gotten negative 6 and negative 7. Look at it. When you multiply the two, negative 6 and negative 7 is positive 42. When you add the two, you get negative 13. So it is these two numbers that we are going to substitute them at that point. And what do we get? We get 2y squared minus 6y minus 7y plus 21 is equal to 0. So at that point, we factorize this part and we factorize this part. So we look at what is common in 2y and in 6y. We have 2y itself and we are left with a y. When you factor out 2y in 6y, we are left with a 3. Minus. What is common in 7y and in 21? We have a 7 being common. And viewers, very importantly, let us look at it. We factored out negative 7. So in 21, we have to be very creative there and see to it that we do not change the sign. So we are left with y here and negative 3 is equal to 0. Why is that so? Negative 7 multiplied by negative 3 gives you back 21, positive 21. And that way we are able to get it done. So we put like terms together. We do the combining of the factors. This and this comes together as 2y minus 7 into y minus 3 is the one is equal to 0. So at this point, we take the factors. I take on the first one, whereby I say 2y minus 7 is equal to 0, and that means 2y is equal to 7. Y is, we divide this by 2, and we get 3.5. Y is 3.5. We come to the other part, whereby we are having y minus 3 is equal to 0, therefore y is equal to 3. It is at that point we come back to our equation, the simple equation here, and find out what is the value of x. So we are saying that x is equal to, we take on 13, we subtract 3 times the value of y, that is 3.5. And what do we get? When we do that, let us compute that. 3.5 multiplied by 3, that comes to be 15, Kale 1, 9, 10. That is 10.5. So we are saying the x value should be 13 minus 10.5. And what does that come up to? We have 13 minus 10.5. That gives us, we borrow 1, we get a 5. This is 2, that is 2.5. So the x value will be 2.5. Let's come to this other part. If y is equal to 3, then what is the value of x? X is equal to 13 minus 3 multiplied by that 3. So we are getting, this is 13 minus 9, and that comes to be a 4. So as we had done in our earlier case, it is important that we pair them. You get some free space and you pair your answers. This particular answer here and this one, whereby we now have in the first set. In the first set, we had the solution. X is 2.5 while y is 3.5. And the other set of answers give us that when x is equal to 4, then y is equal to 3. So viewers, if now we look at the final step towards solving this question, we are saying that the first very important step is when the student is able to give the equation linear substituted into the quadratic, and that opens up his working, M1. We await for him to develop a proper quadratic equation and a correct one. At this level, that earns him an M1. The student factorizes, gets the correct factors, and that earns him A1. And when the student is able to get the two sets of roots, all final answers accurately, we award an A1. And that way, the student is able to score 4 out of 4 in such kind of a question. A little bit lengthy, so we award 4 marks in this case. So viewers, we are now going to have another set of 2 questions which you will solve, and then I will provide you with the answers. So you can pause on the video, we work it out, and then we are going to provide the answers. Viewers, welcome back. Let's look at question number 3. In question number 3, we are required to solve for x and y in the 2 pairs of simultaneous equations given here. Looking at this, the first equation is the linear equation. This is the linear equation, whereas this is the quadratic equation. So we bring in the linear equation into the quadratic equation. So looking at this, 3x minus y is equal to 9. If we push this y on this side and x here, what do we get? We get that 3x minus 9 is equal to y. And that means the y value is equal to 3x minus 9. So it is this equation for y is equal to 3x plus 9, which we shall substitute at that level for y. So equation 2 becomes x squared minus xy is equal to 4. So removing the expression y and substituting it into with 3x minus 9, we get x squared minus x into 3x minus 9 is equal to 4. Opening up the brackets, we get x squared minus 3x squared plus minus x by negative 9 is positive 9x. We bring in this 4 minus 4 is equal to 0. We put like terms together here and we get 1x minus 3x is negative 2x squared plus 9x minus 4 is equal to 0. Viewers, we need to remove the negative on x squared, and that comes to be, we multiply by negative 1. We multiply by negative 1, and that comes to be 2x squared, positive 2, minus 9x plus 4. Let's check that again. Minus by minus is positive. Positive by negative is negative. Negative by negative is positive, and that is correct. So we look at this quadratic equation, which we solve by factorization. We look for 2 numbers whose product is 8 and whose sum is negative 9. So viewers, take 1 minute, look for 2 numbers whose product is 8 and whose sum is negative 9. So easily, we get this as negative 8 and negative 1. Multiply the 2, we get positive 8. Add the 2, get negative 9. So it is this pair of numbers which we shall substitute at this middle term. And we get 2x squared minus 8x minus 1x plus 4 is equal to 0. So we factor out what is common in the 2, and we get 2x is common. We are left with x minus 4. Subtract. We factor out 1 as the common value in negative 1x and in 4. So we have factored out negative 1 even in positive 4. And that leaves us with negative 4. So that negative 1 by x is negative 1x. Negative 1 by negative 4 is positive 4, and that comes to be 0. So at that point, we put the factors together. We have 2x minus 1 is equal to 0. And maybe before we get that level, we get x minus 4 is also equal to 0. So we do the factors here as 2x minus 1 is equal to 0. Therefore, 2x is equal to 1, 1x is equal to a half, or what you can call 0.5 in the positive. So that comes to give us the second portion here. X minus 4 is equal to 0. X is equal to 4. Now we need to look for the value of y in each case. We substitute that value here, and we get that y is obtained by multiplying 0.5 is our value for x, then subtract 9. So this comes to be 1.5 minus 9, and you get y to be negative 7.5. Alongside here, we also get y to be equal to 3. The x value is a 4 minus 9. That is equivalent to 12 minus 9, and that gives us a 3. And that, very important, before we depart from this question, we need to pair the answers. By pairing, we bring in the answers, and we say when x is equal to 0.5, y is equal to negative 7.5. Along the same, in the second part, when x is equal to 4, y is equal to 3. So either marking to this, when we mark on this one, we see that when the student is able to substitute the linear equation into the quadratic equation correctly, we give him an M1. The question is now open and correctly started. When the student is able to form a proper quadratic equation, then we give him an M1. Getting the factors of that quadratic equation is an M1, and getting the two answers accurately, here it is A1, and the student is able to score 4 out of 4 in that set. So viewers, I believe we are getting good skills in solving this kind of linear and quadratic equations simultaneously. And now, I would like us to look at a challenge. I'll provide you with the question number 4 and 5 together with the final answers. Work on them and give me the final remarks as having gotten the answers or not. So we are providing you with the questions, work on them, and the expected answers are as shown here. When x is 9, y is 8. When x is 13, y is a 4. In question number 5, the expected answers are that when x is 3, y is 5. And when x is 5, y is 6. In the remarks section, let me know of your experience in solving the number 4 and the number 5. Viewers, we come to the end of our lesson today, and it has been very interactive. I look forward to meeting you in our next lesson, which is coming up. In our next lesson, we shall look at errors and approximations. This is a topic which at times is challenging to the runners, and I believe that with the exposition that we shall have, it will turn out to be quite easy. Thank you for watching. Do share, subscribe, and comment on the video. I am your online teacher, Steve Gitao. Thank you, and see you next time.